Hi everyone. I wanted to quickly go over this week's lab, which we are looking at the energy lab this week. So just like we did a few weeks ago when we were talking about carbon emissions, this particular lab is focused on what is creating those carbon emissions. So in our carbon simulation we did a few weeks ago, we know that there were fossil fuels and there was a smokestack, and we know that it was emitting carbon dioxide into the atmosphere. But we focus more on where that carbon was ending up in the carbon cycle. This time what we're going to do is we're actually going to focus on the mix of energies that are creating that carbon. So just as before, what I have is I have a link to the Energy Lab simulator. So when you open up the simulator, it's going to look something like this. So please make sure that the lesson that you are working on is managing resources. And then from the lab, what you'll see is that we have a data table to fill out here. And our first data table is looking at the percent of energy that we're using by different sources of energy, the amount of carbon dioxide we are creating, and these are the particular decades that we're looking at. So let's go back to the simulation. So we start in the year 2010. And we're going to assume that each year we need 2%, each year we need 2% more energy than the year before in order to meet demand. So the first thing we're going to do is we're going to take a look at this pie chart down here, and we're going to put in the data table how much of each of these types of energy are currently being used. So again, everything's color-coded down here. So we know that we are primarily using oil, coal, and natural gas right now. Those are sort of our big contributions. And again, you'll notice next to each one there is a percentage. So gas, it says 114 joules and 22%. So what I'd like you to put in your data table is that 22%. So you would go to the year 2010, you would go to where it says gas, and you would type in 22. So you don't even have to put the percent, because I know that all the numbers are in here are by percent. So after we have completely filled out that table with all of our energy here, the next thing I want to figure out is how much carbon dioxide is currently being produced. So I'm going to go here and I'm going to hover on the year, and again we're at 2010, and there were 390 parts per million of carbon dioxide in the atmosphere in the year 2010. So again, I'm going to go back to my table, and under amount of CO2, I would put, what did I just say? I've already lost it, 390. So you would put 390. All right, so you're going to complete that for 2010. Before you do anything else, you're going to put all your data in this table first. Next, we have to figure out how we are going to increase energy so that we can supply a growing global population. So that's when we're going to hit this Add Energy button. So the Add Energy button gives us all of our sources here, and you can also see this is also sort of a quick way to also look at what's currently being used. So the percentages that are in the pie chart down here are the same as the percentages that you currently see here. So you can double check you have the right answers if you want to do it that way. But that's before we make adjustments. So what we have to do is we need to come up with 113 more joules of electricity in order to meet the next decade's demand. So you get to decide what you want to adjust in order to meet that demand. So it's going to be a combination of different sources. So you can increase the amount of oil we're using. You can increase the amount of biofuels we're using. Let's say I wanted to increase the nuclear energy. I could do that. But you'll notice every time I adjust a slider, the amount of energy that we need goes down. So what I need to do is I need to get to 0. So I'm going to adjust things, and again I'm just kind of playing with it here. You can adjust it in any way that you want, but we're adjusting things, and then oh yay, I met the demand. So I have enough of that energy. So I'm going to hit the apply button. And so what you'll notice now is that the percentage of our energy contributions have changed, right? I dramatically increased the amount of biofuel that I'm using compared to what we were using before. I jumped it up to 53%. Okay, and then again, our other energy sources have adjusted here as well. So once again, I would go back to the table, and for the year 2020, I would put in all of the new percentages that I have just figured for meeting the new energy demand. And I will also go here then to the end of our atmospheric CO2 graph, and I'm up to 408 parts per million. So that's what I would put in my table. So you'll do that again for, once again, the year 2030 and the year 2040. So you'll do that until you get to 2040, and then you'll answer some questions. And then what we're going to do is we're going to sort of focus on this idea of what happens when we are solely meeting our needs using mostly non-renewable sources of energy, and then what happens when we're meeting our needs with mostly renewable sources of energy. So we're going to look at those two groups kind of separately. So you'll need to come back to the simulation and hit reset. So you'll go back to the original components as far as oil's 33, coal's about 30, and gas is about 22%. So you'll go back to those original numbers. You're still going to hit the add energy button just as you did before, but this year we're going to try to get all the way up to the year 2100. So in our previous activity, we only did 4 different decades. Here, I want to go for 100 years, and I want to try to see if we can meet energy needs for the next 100 years. So in the first run, once again, you're going to focus on fossil fuels first. So you're going to adjust the sliders with mostly oil, coal, and gas. Okay, you can include nuclear in that as well. It's not considered a fossil fuel, but it is considered a non-renewable source of energy, so you can adjust that as well. So again, you're going to primarily try to meet your goals with just these things, right? And you'll notice that some of these you'll max out on, right? So you can only increase them up to 40%. That's the most that you can increase them in any given decade. And again, some are 40, some are 30, some are 15. It just kind of depends on the energy source. So I'm still short on energy here. So now that I've maxed out my fossil fuels, now I can do something else like a biofuel, for example, right? Then once again, we hit apply, and you'll write down your mix of energy sources once again in your table, and you'll also make sure you're going to look at that amount of CO2. So you'll continue to run the simulation over and over and over again. Once again, we are trying to, we're trying to get to the next decade and the next decade and the next decade. So you'll hit run decade, okay, each time, and then add energy. Okay, so run decade, add energy, run decade, add energy, and then you adjust the sliders. So it's pretty straightforward. And again, the numbers are a little bit, hopefully a little bit clearer than they were in the carbon simulation. You are simply keeping track of, once again, the percentages. You can either get those from the original pop-up window here, or you can get them from the pie chart down here. It doesn't matter, it's the exact same information. And once again, you are tracking the CO2 in the atmosphere. So if you have any questions at all about the lab or running the lab, once again, this lab does not need Flash to run. It's not a Flash-based extension. So I know that was a problem a few weeks ago when we did the drinking water lab. This lab is not a Flash-based extension, so you should be good to go. But once again, if you have any questions at all, please let me know. Good luck, everybody.